Okay, this is the first half of section 5.3 in precalculus. This is all about solving exponential equations. Now, we're actually going to talk about two different methods to solve exponential equations, but we're going to do it in two separate videos. So the first video is over the first method, okay? So the first method is the same base method. Same base method, okay? So for the same base method, you look at the base on each side of the equation and you look to see if you can change them into the same base. Okay, here's what I mean by that. On number 1, on one side, your base is 1 over 8, right? On the other side, your base is 4. You're like, what do you mean your base is 4? Well, isn't this kind of like a 4 to the first? Okay, so what I'm going to do is I'm going to change the 1 over 8 to be a base of 2. So 2 to what power is 1 over 8? Well, wouldn't that be 2 to the negative 3, right? Because 2 cubed is 8. And then since it's in the denominator, it's really to the negative 3. Okay, but that 1/8 is actually being raised to the x plus 1, right? Okay, but I got that to be a base of 2. On the other side, I have a 4. Couldn't I write that as a base of 2? I could write it as 2 squared. So do you see that the base over here is 2 and the base over here is 2? So I got the same base, okay? If you can get the same base, which we did here, and by the way, this is a very common ACT, SAT type solving question, okay? If you can get them to be the same base, then all you have to do is set the exponents equal. But you have to be careful because, yeah, the exponent on the right is just 2, okay? What's the exponent on the left? Well, if you have an exponent being raised to another exponent, how do you combine those exponents? Don't you, like, for example, if I have x squared and I raise it to the 4th, how do I combine those? Don't I just multiply? Wouldn't it become x to the 8th? So over here, really, it's going to be 2 to the whatever negative 3 times that is. So my new exponent is actually negative 3 times x plus 1. So I'm setting my exponents equal to each other. Well, once I do that, isn't this going to be a pretty easy equation to solve? I mean, this is pre-algebra, right? Negative 3x minus 3 equals 2. Add your 3, and then divide by 3. So x equals negative 5/3. Okay, same base method. Look at number 27. Can I get the same base on both sides? Well, the 27 I could write as a base of 3. That'd be a 3 cubed. And that 27 is being raised to the x minus 4. On the other side, the 1/9, I could think of that as a 3 to the negative 2. And that's being raised to the 2x plus 1. So because when you raise one power to another, what you actually do is you multiply your exponents. So that means this exponent has to equal this exponent. So in other words, 3x minus 12, that would be the exponent on the left, has to equal, and I'm going to have to distribute the negative 2, has to equal negative 4x minus 2, which will be the exponent on the right. And now you can just solve a very basic pre-algebra problem, right? I'll move my x's to the same side. I'll move my numbers to the same side. So if I add 12, that's going to be a 10. So x equals 10 over 7. Okay. Now, sometimes people think it's more involved when you have fractions, but here's what I'm thinking to myself. Think of 3/4 as its own base, okay? Thinking of 3/4 as its own base. So I'm just going to leave this as a 3/4. That's my base. And it's being raised to the x plus 2. Look over here, 16 over 9. Would you agree, 16 over 9, let's see if this makes sense. You see that the square root of 16 is 4 and the square root of 9 is 3. So what if I did this? What if I thought of 16 over 9 as being 3/4 to the negative 2? Would 3/4 to the negative 2 equal 16 over 9? Well, the 2 means you square it. You got 9 over 16. But what does the negative do? Doesn't it flip it? So wouldn't that equal 16 over 9? Okay, so do you see that I've changed 16 over 9 to be a base of 3/4? But remember that 16 over 9 is being raised to the 3 minus x. So that 16 over 9 is being raised to the 3 minus x. Okay, but I have the same base. So the exponent on this side has to equal the exponent on this side. So x plus 2 has to equal negative 6 plus 2x. And then if I solve, let's see, I'm going to get x equals 8. Okay, so that's the first kind of solving exponential equations where you have the same base. So like I said, we're going to do this section 5.3 in 2 separate videos. So this is the first half of 5.3.